Hello, we're going to give you a brief introduction of EnView's Scan, Fit, and Measure software and their scanner to give you an idea of what we've come up with as a very, very simple application to measure relatively flat parts or parts that are certainly less than 1 inch in height. The system consists of the flatbed scanner. And again, what we've done is taken a normal scanner and industrialized it. We put it inside a case to ruggedize it so that you can put it on the shop floor and have it sit there without being damaged or broken. It's pretty well closed up so that even the dirt or contaminants that you would normally have in a shop won't hurt it. To measure a part, it's very simple. I take a part, we put it on the stage, we close the window, I say open, I select the file, open the file, and I tell it to scan. Right. What it's doing now is it's going to go down and look and see how many parts we have on the scanner and if they're located within the scanning window. The scanner can measure 5 parts at a time. The total measuring range now is only 5 by 7.5 inches on the scanner. So if the 5 parts will fit in the 5 by 7.5 inch region, then we can measure all 5. So right now the scanner has found the single part in there. It said we have the right CAD file application to run with it, and it's going to go through and now scan it. What it does now is it's going to go through and fit it. We end up with 2 different windows. The software that we're using is a version of MeasureFit. For those of you that have used MeasureFit in the past, you'll recognize it completely. So we've got our image now that we've scanned. Right now you can't see it very good, but we'll get close-ups later. It's showing a green outline around the part. If we go to the scan fit side, you'll see the normal MeasureFit image that you're used to with the whiskers. And again here we can see the profile as well as the dimensions. Now some people only want dimensions, so if we go up and click the 3rd tab, which is Scan Measure, we can show only the dimensions of the part and print that out. For the output, we're using ProLinks QC Calc. We're using the same report output that we use now with all of our products. This package, as well as MeasureFit, has your full geometric dimensioning and tolerancing capabilities. On this part, we measured the center hole. I set it as a datum, and then when we measured the outside of the gear, I constructed a circle, and I asked it for the concentricity to the inside, and here it says it's 6 thousandths. If I want to measure another part, I open up the scanner, put the next part in, and again, I place it someplace near the center, say open, load the file. I don't want to save any changes I made, say run. Again, it's going to show us the old picture, the last part that it scanned, until it looks at the first part. It's going to scan now, do an initial scan to make sure that the part is within the measuring envelope, again, which is 5 by 7.5 inches. As soon as it do that, if it recognizes the part and sees we have the right file there, it'll start the scan for the remainder of the part. The scans take up to approximately a minute. It depends on their size and certainly how much of the window they're filling up. Again, it's done, it's doing its fitting now, calculating the dimensions. Okay, so we have our image, the scan fit, and again here we're showing everything that we would normally show in MeasureFit. We can show the profile tolerance of the total surface or any part of it. I can change the magnification of the whiskers if I want to, because we're going out the same things we would do in MeasureFit. If all I care about is a dimension drawing, then we can physically look at the dimension drawing. And again, on either one of these windows, I can turn on as much or as little as I want. If I want to have all of the points that we physically had with the standard MeasureFit, we can have everything turned on or turned off the same way you would. But again, you can end up with a nice clean drawing of the physical part that the customer can supply to their supplier. right, what we're going to do now, I want to measure one more part before we stop. Take one off, put another on. And again, this is just to give you an idea of the ease of operation. You know, people have asked for the black box for years. And certainly this is as close as I think we're ever going to get to it. From an operator standpoint, the only programming necessary on this before the operator gets to it is someone who has a basic understanding of measure fit. Again, we've taken a lot of the capability out, a lot of the things that measure fit do that doesn't pertain to what we're doing here are gone. And we won't use the full package in this at all. It's the abbreviated package that we're using. We found the part. And again, it says number 1 under the part. If I had 2 parts on there, it would say number 1 and number 2 that it found. The orientation, again, isn't critical. I can put the part on pretty much any angle they want. I'm going to set it relatively straight, relatively near the outline of the CAD, just because the fitting is quicker if it does it by itself. Again, I don't have to do any of the extraneous manipulation to get anything to happen with this. Once it physically does its scan, it gives you the results and you're done. Now the computer we're using this is a pretty high-level computer. Certainly we need something with a lot of computing power. We're taking a ton of data points. In order to get it done in a reasonable amount of time, you need a computer that will physically let it go fast. Again, we've shown what you're used to looking at as a measure fit image and then the dimension drawing. And again, any of the GD&T calculations that you normally make, you have available to you in this. All we're going to do now is rearrange the camera so we can get a close-up of the monitor, and that'll give you the ability to see exactly what we're doing as we're going through this. What I'm going to do now is go through and show you what it takes to program it and make this work. First thing I want to do is load a DXF file, and we'll load a file for the last part we used. We get a preview of it so I can see it, and I just say open. Right, at this point now I decide what I want to do. If we go over and look at the feature list on the right, the software automatically groups all of the features for me together. So if I want to do profile of the total part, which in many cases we want to do on these kind of parts, it's already there for me. If I don't want a group of the whole part, I would delete this step now. As well as with measure fit, the first thing I have to do is do your automatic material identification. I can tell it to calculate. I got on the wrong side, so I switch back. I'm inside the part now. We've got the edge right. All right, number 1 step always. All right, the next step, if I want to go back and I want to assign a profile tolerance, I already have my group. I just come back, assign the tolerance, and I'll give it a point plus or minus 10 thousandths tolerance. I can go back now and start doing any of my dimensional checks. If I want to do a single line dimension or a single object dimension, the same way we would with measure fit, just pick an object and we have it there. If I want to do a width, if I want to do another width, if I want to change my tolerances now, cancel the mode. Put in a tolerance, we'll make them 5 thousandths or whatever it said it was on the print. Oops, not too many there. Okay. Diameter, we'll make it 2, a little bit tighter here. And again, I put in the plus, it automatically fills in the minus for me. Make this 5 thousandths also. Right, at this point, I'm done. If I want to scan the part, I can either save it now as my routine, or I can just put the part on. I'll put the part in the scanner. And what I'm going to do this time, I'm going to cock the part certainly more than we did the last time. All right. Again, this is the picture of the image from the last scan that we did. It's scanning right now. It'll see that we have the correct part for the application that we're running and that we have it within the capture range of the scanner. Again, the measuring range is 5 by 7.5. Now again, the whole purpose of this is to create something that's very simple to learn, very simple to use, and can be very productive in the shop immediately. The programming on this is something that anybody can be taught very, very quickly. It doesn't take a high-level guy. You don't even really have to understand measurement because all you're doing is physically selecting the features that you want dimensions between. If you're going to establish your geometric reference frames, then you have to have the print certainly. Go back and set your A, B, and C datums. If you want to do your angularity, if you want to do your true position or concentricity, then you would go back and physically have those set. It sits now calculating the dimensions. Again, this can be used for metal extrusions, plastic, anything that you would physically see. Again, we don't have it magnified right now. If I come back and we just turn on the magnification of the lines, and we have it. And again, right now we're just doing the center circle. If I go back to the scan measure just shows me my dimension pieces. To run another part, just so you can see what it looked like when we were doing another part, I'm going to put one of the other pieces on we used. I'll tell it to open it. I don't want to save any changes, and we'll tell it to scan this. Again, we're always going to show the last picture that was in the image window. And the scanner can also be used for any kind of gaskets, anything under an inch. Realistically, the flatter the part, the better. So if you could stay half an inch or less, it's better. If you look at it in the image now, you can see a wall when that picture is blown up. And we can correct for the wall effect, but if we can get rid of it, it's still better for us. From an operation standpoint, again, all the operator does is load a part, you select the correct part program, and then you press the scan button. That's the operation of this. Again, for the output, we're using ProLink's QC Calc with their report writer, real-time stats. And I think with the separate dimensional and profile views, you can have whatever you need from an evaluation standpoint without somebody coming back and saying, I have too much or I have too little. I think this is, I guess I'm going to have to go back and say we didn't even put anything in this one. It's one I just did and physically didn't do anything with. So we can go back now if we want to and physically do any dimension that we want. I guess I hadn't done the program, but to go back and select whatever you want for your evaluation. If you want a radius. Go back again to a dual point. I want to measure an angle, the arm, to see where we are here, what the physical angle is. Put it over here. So you have the ability in reality to go back and measure pretty much anything that you want to measure on the part. And certainly in a much easier manner than you would with most other tools. So you're replacing your calipers, your micrometers, the comparator is no longer necessary. We don't have to build charts. All that's done for you right here. And this realistically could be a very, very valuable tool in any shop. The machines are available to you at this time. Certainly, I'd like you all to have one. I think they're a very viable tool, and there's a great application in the marketplace for them today. That's it for right now. Certainly we'll get back to you later with more information.